Product and quotient rules, part 5. Find the equation of the tangent line to the curve h of x is equal to x squared minus 1 over x squared plus x plus 1 at the point 1, 0. If we're trying to find the equation of the tangent line, that means we're looking for some sort of y minus y1 is equal to m times x minus x1, where m is equal to f prime of x1, because the slope of the tangent line is equal to the derivative at that point. So we need to find h prime of x because we actually already have our point. So we already have that we need to use y minus 0 is equal to m times x minus 1. So we just have to find that slope m. So h prime of x will be equal to, and for this we have to use the quotient rule. So we have low, so that's x squared plus x plus 1, d high, so the derivative of our numerator, which will be 2x minus 0, minus high, so x squared minus 1, d low, so 2x plus 1 plus 0, all over low, so all over x squared plus x plus 1 squared. And then we need to find h prime of 1. So we'll substitute 1 in for x now. So we have 1 squared plus 1 times 2 times 1 plus 0, or minus 0. Not that that makes too much of a difference. Minus 1 squared minus 1 times 2 times 1 plus 1 plus 0. All over 1 squared plus 1 squared. So this will be equal to 3 times 2, so that's 6, minus 0 times 3, so that's just 0, over 3 squared, that's 6 over 9, which is equal to 2/3, and that's our slope. So our final equation will be y minus 0, so just y is equal to 2/3 times x minus 1. And that is the slope, or rather, that is the equation of the tangent line to h of x is equal to x squared minus 1 over x squared plus x plus 1 at the point 1, 0. Find the velocity and acceleration functions for the position function, s of t, is equal to 3 to the t times negative t squared plus 4t meters, where t is in seconds. So all this is asking us to do is to find several derivatives, because the velocity is the rate of change of the position function, and the acceleration function is the rate of change of the velocity function. So they're derivatives of each other. So s prime of t will be equal to v of t, the velocity function, and we'll have to use product rule to find the derivative of s of t. So that will be equal to the first function, 3 to the t, times the derivative of the second function, so negative 2t plus 4, plus the second function, negative t squared plus 4t, times the derivative of the first function, which will be 3 to the t ln of 3. And then we'll want to find the next derivative. So s double prime of t is equal to v prime of t is equal to a of t, which gives us our acceleration. We'll have to use product rule for this piece, and then product rule again here. So let me just color code that a little bit. So for our first product, we'll have the first function, 3 to the t, times the derivative of the second function, which will be -2, plus the second function, -2t plus 4, times the derivative of the first function. So that's 3 to the t ln of 3. And then we have to use product rule again to find this next piece. So that will be equal to, for the next space, the first function, -t squared plus 4t, times the derivative of the second function, keeping in mind that natural log of 3 is just a number, so that's along for the ride. So we have our 3 to the t ln of 3 from taking the derivative of 3 to the t, and then we have our original just ln of 3 that's a constant following us along. So that's the first function times the derivative of the second, plus the second function, so our 3 to the t ln of 3 times the derivative of the first function, which is -2t plus 4. And this whole piece here, which is a very long function, will be acceleration, and this top function here is our velocity.